I'm now moving on to the homework questions in lesson number 4 in the radicals chapter. And in this lesson, we'll focus on dividing radicals and also rationalizing the denominator. All right, so let's take a look at question number 1a, root 24 divided by root 3. If you want, you can write this as a bigger radical by having 24 on your numerator and 3 on the denominator. And 24 divided by 3 is going to be 8. So this simplifies to root 8. And then although root 8 is an okay answer, you can further break down root 8 by using a tree diagram. So two numbers that multiply to 8 are 4 and 2. And the 4 can break down to two twos. And then let me just box the prime numbers here. Get rid of that 4. And there's my pair there. So root 8 is the same thing as 2 root 2. So my final answer of root 24 divided by root 3 is going to be 2 root 2. Okay, let's move on to letter B. For letter B, I can write this into a bigger radical by doing the numerator, 56 divided by the denominator, which is 8. And 56 divided by 8 is 7. So my final answer here is root 7. Okay, let's move on to letter C. For letter C, let's go ahead and write a bigger radical sign here. And we can have 72 on the numerator and 6 on the denominator. And 72 divided by 6 is going to be 12. So I can simplify my answer to root 12. And for the 12, I can break down using a tree. So this is going to be 4 times 3. 3 is a prime number, so I can box that. And 4 breaks down into 2 times 2. And those are prime numbers, so I can box those. And then that 4 goes away, and I have a pair of 2's right here. So my final answer here is going to be 2 root 3 as a final answer. Okay, let's move on to letter D now. For letter D, I have a 3 on the outside. So I can write the 3 on the outside like that. And this part right here I can write as a bigger radical as 35 over 7. And if I take a look at 35 over 7, that's simply going to be 5. So I have root 5 as my radical, and then the 3 can just tag along as 3 root 5. So 3 root 5 is my final answer for letter D. Okay, let's move on to letter E now. For letter E, I have these outside numbers, 6 and 2. So 6 divided by 2 is going to be 3. And then I have root 18 over root 16, so I can write that as a bigger radical as 18 over 6. And 18 over 6 is going to be 3, so 3 on the inside. And then the radical sign, and then the outside 3 can tag along. So my final answer is 3 root 3. Okay, let's move on to letter F. For letter F, I have these outside numbers, 5 and 2. I can't simplify 5 over 2, so I can leave that as 5 over 2. And then I have this radical expression there, root 30 over root 15. So I can write that as a bigger radical with 30 as the numerator and 15 as the denominator. And if I take a look at this inside fraction here, 30 divided by 15 is going to be 2. So it's going to be root 2. And then the 5 over 2 just tags along on the outside. So 5 over 2 times root 2 as a final answer. Okay, moving on to letter G. Let's take care of the outside numbers first. 4 divided by 2 is 2. And then I have root 20 over root 5. So let's write that as a bigger radical. And that's going to be 20 on the numerator and 5 on the denominator. 20 divided by 5 is going to be 4. So 4 on the inside, the root sign, and then 2 goes on the outside. And I think most students know that root 4 is going to be 2, so this is the same thing as 2 times 2, which is going to be 4 as a final answer there. Okay, let's move on to letter H here. Okay, so for letter H, 3 over 6 is going to be 1/2, so we're taking care of the numbers on the outside. And then root 12 over root 3. Let's write that as a bigger radical. And let's just have 12 over 3. And 12 over 3 is going to be 4. And root 4 is going to be 2, right? So anyways, I will write this out the long way. This is 1/2. And then root what? Root 4, and root 4 is going to be equal to 2, so now we have 1/2 times 2, and I guess the 2's can cancel off, and your final answer is simply going to be 1. Okay, let's keep on going on. Letter I. Letter I, you should recognize that there's an invisible 1 in front of the root 8. So if I look at the outside numbers, 1 divided by 2, I can't simplify that, so I'll leave that as 1 over 2. And then I have root 8 over root 24, so let's write that as a big radical sign. And that's simply going to be 8 over 24. And if I take a look at this fraction 8 over 24, that's the same thing as 1/3. So 1/3 with the radical sign. And then we'll have the 1/2 in front. Okay, so from here on, what we have to do is we have to take care of this expression right here. This one doesn't really work out to be a very nice answer here. So let's take care of the 1/2 first. 1/2 goes in front. Now, if I take a look at the numerator here, I can write this as root 1 on the top divided by the denominator, which is going to be root 3. And if I take a look at root 1, well, root 1 is simply going to be 1. So if I just do 1 times 1, I have 1 on the top. And then I have 2 times root 3, which is 2 root 3. And although this is an acceptable answer, you can further simplify this by rationalizing the denominator, which is what we're going to do in the next part of this homework assignment. And the way you rationalize the denominator is by doing this. You take a look at the radical on the denominator, and you want to times top and bottom by that exact same radical. 1 times root 3 is going to be root 3. The 2 remains on the bottom, but if you take root 3 and times it by root 3, you just get a single 3. And then you can further simplify this by taking care of the denominator. So if I do 2 times 3, that's going to be 6. So my final answer is root 3 divided by 6. Okay, so that one did take a little bit of work in terms of simplifying, but with a little bit of practice, you should be able to write that down. Okay, let's move on to letter J. I'm going to erase all this. For letter J, there's a few things we could do. I will start off with the 4 and the 9. So 4 divided by 9, I'll leave that as a single fraction on the outside. Now, regarding the 27 and the 32, if I think about the fraction 27 divided by 32, I really can't reduce that fraction using traditional simplifying methods. So what I'll do on the side here is I'll focus on the numerator here in green. So I have a root 27, and what we're going to do is we're going to break this down using a tree diagram. So two numbers that multiply 27 are 3 and 9. 3 is a prime, and then I can break down the 9 into 3 and 3. So the 3's are my primes, and I can get rid of this 9. And notice I have a pair right there, so this simplifies into 3 root 3. So 3 root 3 is what I will replace root 27 with. So I have 4 over 9 times 3 root 3 divided by, okay, and then I'm going to erase all this. Let's take a look at this root 32 over here. So now I have a root 32, and using a tree diagram, I'll break this down. That's going to be 4 times 8. 4 is going to be 2 times 2. 8 is going to be 2 times 4. And 4 is going to be 2 times 2. And then after that, let's just box my prime numbers here. And then after that, let's go ahead and find our pairs. There's a pair, there's a pair. So I have 2 pairs of 2. So root 32 is going to be root 32 is going to be 4 root 2. Okay, so this leftover 2 goes on the inside. And remember, if I take these 2 pairs and I multiply them together, I get the 4 there. Okay, so basically root 32 is going to be 4 root 2. All right, so let me erase all this. So now I take my my 4 root 2, and let's put that underneath here, like that. And let's go ahead and see if we can simplify this a little bit further. And if I take a look at this 4 and that 4, those numbers will cancel off. This 3 becomes a 1, and this 9 becomes a 3. So if you think about this, take a look at that numerator here. The only thing that survives on the numerator is the 1 and the root 3. So 1 times root 3 is going to be root 3 divided by, and on the bottom I have a 3 and a root 2. So I would have a 3 root 2 on the denominator. All right, so we simplified most of it using those operations, and although this is an okay answer for Math 9, let's go ahead and simplify this one more time by rationalizing the denominator. There's a root 2 on the bottom here, so let's times top and bottom by root 2. Root 3 times root 2 is going to be root 6. 3 times 2 is 6. And then root 2 times root 2 is going to be 2. And then the 3 would just tag along. And finally, just to kind of finish this problem off, 3 times 2 is going to be 6, so final answer is going to be root 6 over 6. And that right there is my final answer. Okay, so those ones that did take a little bit of work. Let's go ahead and move on to letter K. For letter K, I have 6 over 7, so let's go ahead and write that down as a fraction. And then I have root 8 over root 2, so that's the same thing as 8 divided by 2. 8 divided by 2 is 4. And root 4, we've seen this a few times already. So 6 over 7 times, well, root 4 is going to be 2. And then if I multiply the 6 and the 2 together, I get 12. So my final answer is 12 over 7. All right, so that was a little bit easier than the two previous ones. For letter I, there's an invisible 1 here. So if I take a look at the outside numbers, that's 1 over 4 times, and then I have this root 7 over root 35. Let's write that as a bigger radical, so 7 divided by 35. And 7 over 35, if I reduce that into a fraction, I get 1 over 5. And then the 1 over 4 remains. And then what we need to do here is we just need to clean up this answer here. So basically there's a root 1. So I can write this as 1 over 4 times root 1 divided by root 5. So I can break down the bigger radical into two individual radicals and divide them. Remember, root 1 here is going to be 1. So 1 times 1 is going to be 1 divided by 4. And then you have the root 5 that's tagging around. And although this is an okay answer, a better answer would have you to rationalize the denominator. So in order to rationalize the denominator, I would take a look at the radical that is on the denominator, and we're going to times the top and bottom of this fraction by that radical, which is root 5. 1 times root 5 is going to be root 5 divided by, well, root 5 times root 5 is going to be 5. And then I have this 4 that just tags around. And then my final answer here, if I just multiply the denominator out, 4 times 5 is going to be 20. So my final answer is root 5 divided by 20. And that's my final answer for that question. Okay, let's move on to the next part of the homework, which is rationalizing the denominator. So back in question number 1, there were a few questions where we did rationalize the denominator. And for this example, the main focus is to just continue practicing that technique. So for question number 2a, there's a radical on the denominator there. So I times top and bottom by root 6. 1 times root 6 is going to be root 6. And root 6 times root 6, since they're the same number, I can just leave a single 6. So my final answer is going to be root 6 over 6. Moving on to letter B. So for letter B, there's a root 5. So I can times top and bottom by root 5. And then let's go ahead and just multiply the numerator. 3 times root 5 is going to be 3 root 5. And then root 5 times root 5 is going to be a single 5. So my final answer is 3 times root 5 divided by 5. All right, 2 more questions to go, and then we're done this video homework guide. The denominator is, the radical on the denominator here is root 7. So I can times top and bottom by root 7. If I multiply the numerators, 3 times root 7 is going to be 3 root 7 divided by, well, root 7 times root 7 is going to be a single 7. And then this 2 is just tagging around. And just kind of finish off this question here, I can multiply the denominators. So my final answer is 3 root 7 divided by 14. So 3 root 7 divided by 14 is my final answer for that question. Okay, let's move on to letter D. So there's a few ways you can do letter D here. So I'll try to use the same technique that I've been using for all the questions in this section. So I have a root 12 there, so I can times top and bottom by root 12. So if I do that, if I do root 20 times root 12, that's going to be 240. So root 240, and then the 3 just tags along, divided by the 4 will tag along. And then just remember, root 12 times root 12 is going to be just a single 12. Okay, so I have 3 times root 240 divided by 4 times 12. We can continue simplifying this for sure. I will focus my attention on this root 240 here. So I will break that down using a tree diagram. So here's 240. And let's go ahead and break this down using a tree. I'm thinking about 24 and 10. 10 is going to be 5 and 2. And these are my prime numbers. And 24 I can use 6 and 4. 4 will be 2 and 2. And those are prime numbers, so I'll box them. And 6 is going to be 3 and 2, so I'll box those guys. And then let's go ahead and now find our pairs. So there's a pair right there, and there's a pair right there. So if I combine yellow and green, that's going to be 2 times 2, which is going to be 4. And then I'm left with a 5 and a 3, so 5 times 3 is going to be 15. So I have 4 root 15 as a simplified radical. So if I go ahead and use this 4 root 15 for the root 240, my next line would be 3 times 4 root 15 divided by 4 times 12. And after that, we can now simplify this. So the 4's can cancel. 3 and 12, that's going to be 1 and 4. So on the numerator, I have 1 times root 15, which is going to be root 15. And on the bottom, I just had that single 4, so root 15 divided by 4 would be my final answer.